Yes, thank you. I got lazy. So a polynomial function is always continuous. Hey, look. Polynomial functions are the easy ones because they just are smooth. They go like this. Okay, not a sine wave that's like periodic. Or like this is a polynomial function. This is a polynomial function. Simple, smooth things. You studied them in a previous class. If you have a polynomial function, they're the easiest ones to work with because you can draw them without ever lifting your pen. That means continuous. And they are differentiable, meaning you can find the tangent slope everywhere. Max, please.
I'm not quite getting it. I think you need to put on the hat.
Oh, I'm not the particle this time, though, so it's okay. So 2 points, though. It's a good suggestion. Yeah, the particles, yeah, I'm just drawing polynomial function. Humor, it's good. 2 more for Max. Okay. Look. Go to your salmon reference sheet. You sound so sophisticated. Salmon reference sheet. Here's a random question. Raise your hand, please, if you would call this orange. I'm just curious. How many would look at this and say, oh, that's orange? How many would say it's more pink than orange? Yeah, you and I are the same. I asked somebody, like, why do you call it salmon? Because that's what the copy center called it, salmon. I don't know. Hey, look, bottom left, find the box. Bottom left, the box says differentiable. Find it? Nod, please. Got it? In that box, there's an equation and there's some words. You'll eventually need the equation. For the first test, you only need the words. The words say a function is differentiable if it is first continuous. So if a function is not continuous everywhere, then you're guaranteed it is not differentiable everywhere. But once a function is continuous everywhere, you've got to check for 2 more things. Got to make sure that function does not have any corners or vertical tangents. That's what that box is telling you. A corner on a function means a sharp point. So polynomials don't have corners. And they don't have vertical tangents, meaning their slope is never straight up.
So does that mean if like a graph had like a jump, then there would be no f prime graph?
Listen to Ethan. If a function, so I got to be really careful how I say it. If f has a jump, that means at that jump, f prime is undefined. Because the values of f prime are the slopes of f.
So it'd just be a hole in the f prime graph.
Yeah, we won't use the word hole, but it will be a place where we don't know the y coordinate.
Would it be one of those little like
It could be. I mean, that's how we'll draw it. We just don't use the word hole for the AP test.
Okay.
So it can cause mistakes, but it is a spot where f prime is definitely unknown. And we draw that with an open circle. Does that make sense? It's good work. 2 more. Other questions? Please.
What does it mean when it says no corner or vertical?
So if you have a graph that has a corner, it's going to look like this. There's a corner. So at this spot, you cannot identify the tangent slope. It's unknown. Question, Maddox?
Are we going to be doing graphs that have that
Yes.
soon?
This test, yes. But look, it's not difficult on the test so far. You just have to look at that and say, oh, that's a corner. So if this is f, if this is at x equal 5, that means f prime when x is equal to 5 is simply unknown. That's all. Is that okay?
Yeah.
2 more. Anybody else? Paige? Good with that?
Yeah, what does VT stand for?
VT is my abbreviation for vertical tangent. So if the function looks like this, the slope right there is unknown because it is straight up and down. That's a vertical tangent. So if this were x equal 3, and this is the graph of f, f prime at x equal 3 would be undefined. Questions? Cool. All right, here we go. So given that information, now we read the problem slow and careful. So go back to here. It says a polynomial function has a relative max at the point -2, 4. I do something different than many math teachers. I find that if I draw a grid, I often have more trouble with the problem than if I don't. So I usually kind of start out without a grid and then see if I need one. It usually is easier to think about without. So there's a point at -2, 4. Just put a point somewhere. Label it. Make sure you keep track that we're talking about f now. Well, actually they call it p, so there we go. So we have a function p of x, -2, 4. There's a relative max at that spot. That means the function p would have to have this sort of appearance. Raise your hand, please. If p looked like that, true or false, would p have a relative max at that spot? So if p looks like this, would that be a relative max of p? True or false? Show me. So I'm going to give a hint so you can get the right answer here. The definition of relative max is the graph of p has a relative max where p changes from increase to decrease. So is this a spot where p has a relative max? True or false? That helped. If you're doing this, give yourself a point. That is definitely a spot. This is definitely a place where p is changing from increase to decrease. But I don't draw that in this problem. Why not? Hands, come on. Come on, come on, come on. Focus. Why am I not drawing that for this problem? Why did I draw a nice curve? This is the AP test. This is your next test, is this idea like you got to keep grabbing concepts. Keep your hands up. What you're used to in previous classes is you pick up the test, you look at a problem, you go, oh, I've done that before. I just need to do it again. That is not going to happen on this test. What you're going to do is what you're seeing here. You're going to read something. What does that mean? It means this. Okay, got it. Now what does this mean? So why, Brooklyn, do we not draw this for this problem? It's a polynomial. How many knew? 0.2 for Brooklyn. Polynomials don't have corners because that would make the polynomial not differentiable at that spot. Polynomials are always differentiable. Questions? Cool. I'm going to keep drawing. Sorry, I'm picking up the pace because the bell's coming. 1, 1's over to the right, down a little bit. Let's see, 5, 7 further to the right, but a little bit higher. Now, because it's a polynomial, it has to be smooth. And it says it has no other critical points. So p has a critical point where the slope of p is 0 or undefined. The slope of p is 0 here. The slope of p is 0 here and here, but nowhere else. So when I continue to draw p, I can't turn. I have to just keep going down. If I turn, p will have another critical point. Questions? Same thing over here. Can't turn, I just have to connect. The question says, how many zeros does p have? Now it's helpful to draw an x-axis, which has to be, let's see, this point was 1, 1. So the x-axis has to be here. A 0 is a spot where where p has a y-coordinate of 0. That's the definition of a 0. Learned that previously. So who knows the answer? Vote. Show me. A, B, C, D, E. What is the correct answer? Doing this, give yourself 2 more. Questions? Awesome.